Hello and welcome to another Algebra 1 video tutorial. In Lesson 10.1 will be an introduction to systems. So our goal will be to understand what it means to solve a system numerically and graphically and find solutions to systems of equations by graphing. Alright, so first of all, what's a system? A system is a set of equations or inequalities joined by the word "and" that together describe a single situation. So let's say this is our system. Y equals 3x minus 7 and this curly brace, the left brace is in place of the word "and." It's just a way to kind of line up our equal signs and combine this into one system. So y equals 3x minus 7 and 2y minus 2x equals 10. So if we're looking for a solution for this, a solution to a system of equations with two variables is an ordered pair x and y so that it satisfies both equations in the system. So what would be the solution here? Now we'll find methods to solve this, but let's say x is 6, y is 11. If it's a solution, that means it satisfies both equations. So in this case, let me check it in the first equation. So 11 is my y equals 3 times x, which is 6, solution, minus 7. And this works because 11 does equal 18 minus 7. It works. Okay, so it checks there. Now, if it works in one, it has to work in the other, or it's not a solution. It can work in one but not the other, but that's not a solution. So now we go 2 times y, checking the bottom one now, 2 times 11 minus 2 times x, which is 6, is supposed to equal 10. 22 minus 12 equals 10. That is true. So that shows that this is a solution to the system because this xy ordered pair satisfies both equations. Alright, number 1 here. Consider the system y equals 4x minus 11 and 5x plus 2y equals 4. Part A, verify that the order 2, negative 3 is a solution to the system. And B, show that 1, negative 7 is not a solution to the system. Okay, so we'll start with part A. 2, negative 3. So I'm going to say, that's the first one. Negative 3 equals 4 times 2 minus 11. That gives me 8 minus 11. 8 minus 11 is negative 3. Okay, so it works in the first one. It's supposed to work in the second one as well. So 5 times 2 plus 2 times negative 3. This is supposed to equal 4. 10 plus negative 6 equals 4. And that is that's true. Okay, so that shows that 2, negative 3 is a solution. Now part B, we have to verify that 1, negative 7 is not a solution. So we say negative 7, I'm using the top equation, equals 4 times 1 minus 11. Negative 7 equals 4 minus 11. Negative 7 does equal negative 7, so it works there. So why is it not a solution? Well, you have to test it in the other one, the other equation as well. So I go 5 times 1 plus 2 times negative 7, and that's supposed to equal 4. 5 plus negative 14. 5 plus negative 14 is negative 9. And negative 9 does not equal 4, so this is not a solution because it doesn't work in both. It works in one, but not both, so it's not a solution there for part B. Alright, let's say a second grade class has 23 students. There's 5 more boys than girls. Solve a system of equations to determine how many boys and how many girls there are in the class. Now this is a simple system that you probably wouldn't need to solve because you could probably use guess and check or a little mental math, but that's not the point. The point is to set up a system, and we're going to start with an easy system so that we can solve a little more complicated problems than such as this. So what would the system be? Well, let's say x is the number of boys and y is the number of girls. So we would have a system of equations. Well, we know there's 23 students, so that just means the boys plus the girls is equal to 23. Now, there's 5 more boys than girls. So we'd take the number of girls plus 5, and that's supposed to equal the number of boys. Okay, so if y is the girls, there's 5 more boys than girls, so the girls plus 5 is equal to the boys. Okay, so now we want to maybe graph this, well, we don't have a way to graph x plus y equals 23 or y plus 5 equals x. So what we need to manipulate these equations like you learned in chapter 6. So I'd probably get them both to be y equals so we can graph this. So I'd subtract x from here. So I'd have y equals 23 minus x. This one I would only need to subtract 5. So I'd have y equals x minus 5. And we're going to solve this system with a graph. So drag out your graphing calculator and let's enter in 23 minus x and x minus 5, and we'll try and look for a solution to this. Okay, in your calculator you would go to y equals, you would enter in 23 minus x and x minus 5. That would be our system of equations. Now in our window we are not going to get negative values, and the most students there are is 23, so let's just go 0 to 23 for both the x and the y. That should get everything, and press graph, and there's our first equation and there's our second equation, and we were looking for the solution where they are both the same, where they have the same x and y values on either one, and we need to go to intersect. So second trace, option 5, first curve is y1, that's question mark. I need to press enter. Second curve is y2. It jumps to that. Good. And my guess is just press enter because that's only going to intersect in one spot here. So I get x equals 14 and y equals 9, meaning there's 14 boys and 9 girls. There are 5 more boys than girls, and there's a total of 23 students, so that answer will check. All right, easy enough, huh? All right, the next example, example 3. Find all the solutions to the system y equals 1/2 x minus 3, and opposite of x plus 2y equals negative 8. Right now, our first method is going to be graphing. In later lessons, we'll have other methods, substitution and multiplication method, coming up. There are other methods to solve these by hand, but at this point, let's use graphing. So we're good to graph y equals 1/2 x minus 3. This equation here is set up to get the x and y intercepts, but let's just solve it for y so that we can graph these. Okay, so if I have opposite of x plus 2y equals negative 8, I would need to add x to both sides. So then I'd end up with 2y equals x minus 8, divide by 2, so I get x over 2 minus 4, right? I just divide every piece, each side and each term by 2, so I get 1/2 x minus 4, and I have, so my new system would be y equals 1/2 x minus 3, and y equals 1/2 x, right? I can write x over 2 as 1/2 x minus 4. And from what you know about chapter 6, you might have an idea of what these graphs are going to look like, but let's graph them and take a look at them anyways. Drag out your calculator if you want to follow along. Okay, so in your y equals, you would enter in 1/2 x minus 3 and 1/2 x minus 4. Let's get a standard window, so I'm just going to go zoom 6. And we have y-intercept of negative 3, slope of 1/2, and we had a y-intercept of negative 4 and a slope of 1/2. So as hopefully you reminded yourself, if you have the same slope, you have parallel lines, and parallel lines do not intersect. So in this case, there is no solution. You'll not find an xy ordered pair that will work for each equation because they're parallel lines with no intersection. So there's no solution, or they call this the empty set or the null set. So you'd be the set of solutions with nothing in it. You could also have that, means no solution as well. So there's kind of 3 ways to write that. Just putting no solution is simple enough. Okay, next thing we'll talk about is cost and revenue equations, right? A lot of math is applied into the business world. So in manufacturing, a cost equation describes the cost, which we'll call y, of making X amount of products. Fixed costs are things like rent, employee salaries, which must be paid regardless of how many products are made, whether you make 1 product or 1,000,000 products. Rent and employee salaries would be a fixed cost. Variable costs, though, would include materials, so the more you make, the more costs you'll have, and shipping and so forth. That depends on how many are made. The total of fixed and variable costs is the amount of money that the business pays out each month, right? You have to spend money to make money. So then the revenue equation, that describes the amount, y, that a business will earn by selling those X amount of products. And then the break-even point is the point at which the revenue and total costs are the same. Okay, and then this point tells the manufacturer how many items must be sold in order to make a profit, or at least it's a great estimate for doing that. All right, last example here. Let's say a cafe has monthly fixed costs of $4,700, and a typical customer order will cost the cafe $2. Therefore, the cost to serve X customers would be this equation, 4,700 plus 2x. The typical order costs the customer $10. So the revenue equation would be y equals 10x. And that probably is an average figured out over a period of time. So find the break-even point for the cafe. Well, first we need an equation, a system of equations. Okay, so we have a cost equation, which would be y equals 4,700 plus 2x. And a revenue equation, which would be y equals 10x. Okay, so we want to know where the revenue equals the cost. So we want to know, when does 4,700 plus 2x equal 10x? Oh, we subtract 2x. Subtract 2x. So then we get 4,700 equals 8x, and divide by 8. Divide by 8. 4,700 divided by 8 is about 587.5. 587.5 is what x is. So you need probably about 588 customers to break even. Okay. I will also show you on a graphing calculator how to solve this as well. We should come up with the same answer. So drag out your graphing calculator if you want to check this on your calculator. Okay, once again, in y equals, you'd enter in the system of equations, 4,700 plus 2x, and y equals 10x. The window on this is going to need to change quite a bit. We're going to x is the number of customers. So since I already know the answer, 587.5, I'm just going to get a good graph here. So let's go negative 10 to 1,000, and maybe count by 100s. And y minimum, negative 10 is fine. We only probably need 0. The y max, if you serve 588 customers and the revenue is $10 a piece, you need to go to 5,880. So maybe let's go up to 10 grand just to kind of see what we see, and maybe count by 1,000s. All right, press graph. We should see at least a decent graph here. We still need to change it. Pretty good graph, just because the main thing that I want is this intersection point. So go second trace. We want an intersection, option 5. First curve, y1, second curve, y2, and a guess. And we get 587.5. And then what this y value means is the revenue or cost, which would be $5,875. But remember, in this case, we would need to round this probably up to get 588, since we're talking about number of customers. Okay, that wraps up this section. Your assignment will be 10-1, page 586, 2 through 20 evens. Thanks for watching, and we will see you next time.